Hello everyone, I'm Will Hurst, Managing Editor at the Architects Journal, and I'd like to welcome you to this AJ100 Club breakfast event. Our guests this morning from Arup Architecture are Director Nick Jackson and Senior Architects Christina Cox and Philip Egan, who are here to discuss their London office scheme for British Land, 1 Triton Square, seen as a model for the reuse of existing buildings and one of the property developer's first BREEAM Outstanding rated buildings. The scheme, located in the West End, was originally designed by Arup for British Land in the 1990s. In updating it for modern requirements, British Land initially looked at a new build option, but then asked how much of the existing building could be retained or reused, setting a clear challenge for Arup, which acted as engineer as well as architect and contractor lend-lease. The resulting project was key in British Land being named AJ100 Client of the Year last September for its pursuit of net zero carbon real estate by 2030. Now, before I hand over to our speakers, I'd just like to extend our thanks to the AJ100 sponsors whose fantastic ongoing support makes these events possible. Thanks to our headline partners, Rocker, and thanks also to our program sponsors, Schluter Systems and Siemens Home Appliances. I'd also like to alert you to another AJ event taking place next Friday lunchtime, the first in a series of webinars featuring some of the new AJ 40 Under 40. The 40 Under 40 programme, brought back by the AJ for the first time since 2005 and supported by Vitra, celebrates the UK's most exciting emerging architectural talent. Our free webinar will feature speakers from Field & Fowles, NIMTIM, Freehouse and Office S&M, discussing the do's and don'ts of setting up in practice. To find out more and to book your place, see the recent web story about this event on the AJ website. So, back this morning, and a very warm welcome to our speakers from Arup Architecture, Nick, Christina and Philip. They will now present 1 Triton Square before we take questions from the audience.
Thank you, Will. Right, let me just share. So hopefully everybody can see that. So thank you for this opportunity just to explain a little bit about the work we've been doing at Triton Square. Building's been on site for 2.5 years, coming very close to completion now, and will emerge just as we come out of lockdown, actually, which will be very exciting. I think everything I'm going to talk to you about this morning really wouldn't have been possible without the teamwork that has gone on between Arup, our client, long-standing client over many years, British Land, and the contractor lend-lease who we're working very closely with. And what we've achieved on the project in terms of the initiatives around sustainability and particularly carbon have only been realized really by the collaboration and commitment from all 3 parties to achieve this. Triton Square didn't come from nowhere. Arup have been working in this sector for over a decade, really, in terms of thinking about circular economy. We've been looking at it from a point of view of investment, experiment, exploration over 10 years. We've worked in that sector developing a framework for property in terms of developing a brief that we use internally around the planning, the design, the use of materials, all building around our approach to circular economy. And this works across our whole business and is a strategy that is growing very rapidly in our thinking and work. Our relationship with the Ellen MacArthur Foundation is well established, and we have very close partnership there. And that has worked through equally with developing an approach to real estate across a number of trial projects we've developed in conjunction with other partners like RICS and JLL, in terms of how we embed sort of circular economy thinking in our approach. So I just wanted to sort of set that the scene really in terms of where the thinking on the project at Triton Square has emerged from. That sits alongside our commitment at Arup to align our business in all that we do to and our activities to the UN's Sustainable Development Goals, the SDGs. As a global organization, we've adopted those 17 initiatives and goals to sort of structure our work at all levels and embed in our strategies around design work and the projects and thinking that we take on. At the moment, we see ourselves as sort of on a journey. We're moving out of a sort of point of sort of green, sustainable design and looking increasingly to how the thinking in our work can lead towards restorative and ultimately sort of regenerative design in the way we approach our work in the built environment. So that just sort of sets the context for Triton. The simple headline really is the work that we've achieved there has saved approximately 40,000 tons of CO2 emissions over the sort of 20-year life of the lease. That is made up of embodied and operational carbon. And obviously there are many ways you can equate that to sort of understand what that means, but in simple terms in what a car does, it's a pretty staggering figure. And that work has come from a whole series of initiatives. There are some headline design changes or design initiatives in the project we've brought to it, but there's a lot of other smaller moves, which I will explain as we go through in some way. So the project, just to give those who don't know the building, when it was pre-let to Dentsu Aegis, it was largest West End pre-let in the last 20 years. We began with a design and brief that was about achieving BREEAM Excellent, and that has moved over the course of the project to achieve BREEAM Outstanding, which is one of the first buildings for British Land, certainly, that has achieved that landmark, and one of the few large commercial buildings of this nature that have been able to achieve that as a sort of standalone building that's not linked into a large energy network. It's 500,000 square feet. We've saved 40,000 tons of carbon through the various initiatives we've brought to the scheme, 54% reduction in the embodied carbon. What we did demolish, which was very limited, and the waste was all diverted to other uses. So things, initiatives like plant that was taken off the existing building has been upcycled and reused, exported and made use of. We've made significant reduction in water usage on the building. If you think the original building was designed in the 90s, a lot of the approaches we can now bring to the design of the building weren't available then. And 80% of the materials we have used, we've been able to responsibly source. We would like that to be higher, but that is sort of a reflection on the marketplace that we're procuring from. The building, for those who don't know, sits in the center of Regent's Place on the Euston Road. It forms part of the Knowledge Quarter, which, as I think everyone will know, is a very vibrant and rapidly changing sector of London on the northern edge of the West End, and becoming increasingly a location for research and academic work that obviously has grown since the Crick opened. To the south, we have Fitzrovia, UCL, and Marylebone with its education institutes and museums and so on. The trigger for the project really gathering pace was the pre-let from British Land that really galvanized the scheme into moving forward. And the approach that we've taken to sustainability and carbon has been embraced by the tenant, by Dentsu, in terms of the way they're thinking about their fit out, which is will start very shortly, fully designed at this point. The building will complete during April and be handed over to the tenant team to progress into fit out. So the sort of thinking that we brought to this, in a way, there are some big moves we've brought to the design thinking, but actually it's all the small moves really that have been the key to the changes we've made. The strategy was to really look in every area of the design, every part of the thinking, and bring the same attention to detail about what can we do to reduce the amount of material we use, what can we do about the carbon content of material, what can we do about the recyclability or the reusability in terms of circular economy thinking to the scheme. So that sort of initiative that one sort of sees, and in sports and so on, and obviously cycling is a sort of obvious reference for that, has been brought to bear in all sorts of parts of the building. So the sort of headline story, like all refurbished buildings, is obviously we've been able to take advantage of repurposing and reusing the existing structure, bringing our engineering thinking to that to minimize the amount of new structure we need to bring to the scheme. The approach to the facades, where we have removed large sections of the existing facades, and rather than replace them to upgrade them, we've refitted them, refurbished them, and brought the same material back on site and reinstalled them, which is, we think, probably one of the first examples of that being done, certainly in the UK, if not in Europe. We've made other changes to the scheme, which Phil and Christina will talk about, in terms of things like changing the staircases, so they no longer sit within the primary thermal envelope and are heated all the time. We've moved those so they're no longer part of the primary heated space. They're tempered so they don't get too cold, but we've moved the thermal line in the building to change the energy usage. We've obviously replaced all the plant on the building and upgraded that very significantly, highly performing plant. We've taken advantage of the capacity of the existing building to allow that to work in a highly efficient way, and a whole number of other strategies that we brought to bear. Arup, the project has been designed by all the disciplines within Arup, so the architecture team who now sit within Arup as a whole, working closely with the engineering teams on the structures and MEP side, lighting, acoustics, sustainability, have all contributed to this at various stages of the project, and particularly in the analysis of the use of the existing fabric and materials. The carbon team within our sustainability team put a lot of work into this in all sorts of areas that probably we hadn't looked at before in the depth we have on One Triton Square. The brief was quite simple to us. To make this make sense for British Land as a development, we needed to double the size of the building. Now, that's a pretty simple metric. Probably most architects on this talk will recognize on a big refurbishment project or a rebuild project, you need to achieve that level of upgrade. That was a challenge with the existing building with its foundation system to create that area without changing the footprint of the building. And we've developed that in a number of places, which Christina will explain. It needed to be highly efficient. We needed to be hitting very high net to grosses. We needed to make sure all the operational areas of the building worked efficiently. Sustainability and well-being were embedded right at the outset in the thinking about the building. So we needed to produce a building that had much higher ambitions in terms of sustainability and carbon energy usage than the original building, but was also still a wonderful building to be in that had really good daylight, really enjoyable building to move around and work in to attract tenant and so on. And that goes hand in hand with the quality. The key value changes we brought to it were we doubled the floor area of the building without changing the area of building given over to plant. It has a single basement, highly constrained. We put a lot of cycling into the building that wasn't there from the 90s building, cycling facilities, and we've got the same area of roof plant we had originally. It's a little bit taller maybe in plant, but that area is working much, much harder in terms of what it can deliver in terms of BREEAM rating, and that required a very innovative approach. So originally we were just looking at BREEAM was the thinking around what could we achieve. And we moved that target from excellent to outstanding over the course of the project, and without really the level of cost increase that one might think was there. Now that cost is related to what British Land would normally see as the budget for a building of this nature, but it was very marginal. It was much more down to where we put the effort and really thinking hard about where we spent our budget in terms of use of materials and thinking about the engineering. So the original building, Arup Associates building, 1998, built probably at the time that sort of, Canary Wharf is really starting to gather pace. It was built as a support building really for a trading bank. It was going to be, built originally with trading capacity, but used by the original tenant was going to be a support building. But it was big building, corner cores, and it's a sort of low-rise, 5-story building that sat and reflected the sort of horizon of Regent's Place at that time. But it was a well-built building, and the key thing is we had all the records and all the information on how it was built. So we had all the drawings, we had all the working drawings from the contractors like Scheldebau, and we had our own design drawings and so on the engineering. And that was a fundamental sort of prerequisite really in terms of the sort of re-engineering of the building that we were able to go through with the new design. Right, I'm going to hand over to Christina now, who's going to take you through the arrangement of the building before we come back to discuss the sort of structure.
Okay.
Christina.
Yeah, so the existing building is quite deep in plan, and it has this unusually large octagonal atrium in the centre of it, with a roof light above that. Next slide, please. So this is just an image towards the end of the demolition phase, where the plant is all removed from the roof. The roof light's been removed, and the top of cores have been removed. So in terms of the original concept for the building, the original design principles included the plan was perfectly square. There's these 4 corner core placements, and on each elevation there are these secondary screens that clad each elevation. And there's also consistency of proportion from the macro in terms of the overall elevation right through to the micro in terms of the individual panels that make up those secondary screens. So when we were considering the refurbishment of the building, it was important to be considerate of these original principles. So the key interventions for the refurbishment included consolidating that central atrium, so bringing that atrium in from 32 metres across to 17 metres, extending the cores upwards. And then when we extended the building upwards, we set back those levels, not only to create some amenity, but also to maintain that consistency of proportion across the elevation. And then finally, just reconfiguring the main entrance area to create a more dynamic reception area that fronts onto Regent's Place. So in terms of the building organisation, the 4 cores serve the office levels, which are level 1 and above, and the ground floor plane, which is mixed use, is accessed via the perimeter. So originally the ground floor had an undercroft that cut right across the centre, and the ground floor facade was also set back. So we've pulled the ground floor facades out to better address the public realm. To the north, there's an affordable workspace area. To the west and centre is a large gym area with a cycle storage area in the centre of the deep plan. To the south is a dedicated secondary entrance for the office, a retail space, and the main entrance facing onto the plaza. In terms of the typical upper levels, as mentioned, the atrium was infilled. So the atrium has a stepped profile to create a more dynamic space. The lifting strategy was looked at, so we've reworked all of that. So the main lift bank now includes an extra four lifts, an increase in the washroom areas in the cores, and also infilling the 6-storey atrium that's sat above the original entrance, not only to create more floor area, but also these smaller balconies that look out over the Regent's Place Square. And so through those interventions, we managed to increase the office area by 85%, and as Nick mentioned, with no additional space for plant required.
Thank you, Christina. So, you know, that within that move to create this almost doubling in the net area of the building, the work we started doing as the project developed in the early stages, we're looking at really the combination of what the operational carbon was, which I think was sort of well understood principle, sits within what we do normally, but starting to look increasingly at the impact of the embodied carbon. And a key factor for us as we look forward to other projects that we're now dealing with is as the energy supply grid increasingly is moving towards all electric buildings. We see really most of the buildings we're now designing of this nature, where we create all electric buildings. As the grid cleans up, the emphasis and the importance of really understanding the embodied carbon in the thinking around design is becoming increasingly critical. And that underpins really, I think, the deep rationale we're now asking ourselves with all our projects really across Arup when confronted with a proposal is there something there we can reuse? Do we really need to replace a building, or is there a way we can repurpose this building? If it's in one use, how could you transform it into another use? And what can we do in terms of bringing all our engineering and design thinking to that to understand the impact of that? Because we see the embodied carbon now as increasingly factor in the overall carbon impact of projects. So one Triton, I mentioned the sort of principle of marginal gains. This slide really is a bit of a sort of encyclopedia of all the different things we tried to do on the building, but it captures the key moves really around the reuse of the structure, the rethinking of the atrium as an animated space at the heart of the building. So it's like a found space really. If you looked at what it was in the original building, it was a sort of pretty dead void. like you find in many sort of 80s, 90s buildings. We've retained the facades to the cores, which Phil will talk about shortly. And then a whole series of other small initiatives really around either really efficient use of the floor plate itself, which is one version of making a building highly sustainable, or simply looking at how we reuse things like, you know, the roof system. We've got recycled paving and recycled ballast that's come off another building that we've been able to use on this building, rather than going out and buying new river ballast and new slabs from the just for walkways. The existing building, 33,000 tons of concrete, 18,000 tons of steel reused. The brown on this slide is the existing structure, and the blue is the new. So we peeled a little bit off the existing building at roof level, took off the roof lights, took off the top of the cores, took off the BMU tracks. We've retained the body of the building, and we've retained all the substructure and so on. There should actually be some piles hanging off the bottom of that pink plate. And then we've basically inserted this sort of new structure in and around the existing structures. So adding floors down over the reception that Christina talked about, inserting new structure in terms of additional piling underneath the building to pick up the load, and then a very light, efficient composite steel and concrete structure going on top with all the concrete GGBS, low carbon concrete. So whilst we might consider now, we might try and explore whether we could use timber for this, though that's still very challenging in commercial buildings. We looked hard at where we were having to use concrete to really reduce the amount of carbon in that. So we have this lightweight steel frame that drops in over the existing building. Our engineering colleagues and the structures team did a lot of work to reanalyze the existing foundation system from the records we had in the design records, and relocate, if you like, or reapportion the way we were using the loading within the building, because the building had been designed for dealing. It had some quite high loading in areas, and we were able to sort of transfer those loading allowances around to create the capacity in the building to get this extra space in and get the building. Down in the ground, that was pretty heavy work in places, working underneath the existing slab. We had a low headroom piling rig in there. Where we could, we were using carbon fiber wraps on columns to strengthen those. And that was in conjunction with threading piles in. So there were localized areas where we had to take the existing slab out to thread piles through. But because of the analysis around the engineering and the way, because we had the records, we were able to have confidence in how we combine new and old. And that meant we could reduce the amount of sort of, if you like, caution going on in some of the design decisions to really make sure we'd optimized the design of that foundation system. So nice view here through the basement while that work was going on. You see in the distance there some little steel frames going up around. So there were one or two columns that actually, despite all that, we couldn't justify when we analysed concrete, the as-built condition of concrete and so on. So there were 5 or 6 columns where we had to prop the building, take out columns, knowing the reinforcement was there, supplement that reinforcement and recast them in key locations around the atrium where they were picking up the highest load. So this is the reformed atrium. Still very, very generous space. It's a fantastic space to be in. And once the tenant is in there, they're adding some staircases in, I believe, to run between floors. Will be a terrific heart to the building. New roof light, that's light down, and it's got a very nice, simple, elegant sort of graphic quality to it. The concrete work, therefore, in the new structure, 59% of that was cement replacement, 40% less carbon in that element than we might have expected in a normal sort of hollow rib type floor system. And then the last sort of part of this, just in this short sort of discussion of what we've done, we're just going to explain to you, Phil's going to take you through the approach to the facade, which is pretty unique, we believe, in terms of work on a building of this nature, really being able to combine new and old structure. So Phil, I'll click through as you.
Yeah, so we had around 3,000 square meters of facade on the building that was refurbished. So this was taken off the building and sent to a factory in Basildon, where it was kind of inspected, cleaned up, gaskets replaced, repaired, and glass panels replaced if necessary. So it's just a photo of that. Go to the next slide. So looking at the building as a whole, So we basically try to retain as much as possible. So not including the kind of main entrance facade to the left-hand side there. We more or less retained the majority of facade from level 1 up to level 6. And we retained kind of all the stone on the cores from ground floor up to level 6 also. So basically the double skin existing on the building is kind of the central part of the building. So the outer of that skin was taken off and that was refurbished. The inner skin was largely retained. Again, that was kind of cleaned up and any remedial works were done. The glazing in the inner skin was taken off and that was replaced by new glazing in order to create a more kind of energy efficient building. The lower part of that double skin was completely removed because the whole facade was moved up one level also. So we kind of took off the lowermost panels. The supporting structure that fixed back to the slab was also modified, and then that was replaced back up on the new level 6 slab. So yeah, if we move on to the cores, as Nick mentioned previously, obviously we're retaining a lot of the facade at the lower levels, and we've got these new glazing panels at the top, which give us kind of great views out and around over to Regent's Park, over to the kind of financial area of the city, and also up to kind of Parliament Hill. So these sorry, can you go back to that one again?
Oh, sorry.
Apologies. So that's a lot of light down into the stairwells, and also we kind of moved the thermal line back towards the office itself. So the existing facade was somewhat leaky, so we thought it was a better opportunity to kind of do that and kind of have a second layer of defence for the building. We can move on. Yeah, so again, moving kind of from top to the bottom of the facade. So at lower level, we removed a whole band of facade, and that was taken off, refurbished, and then put back on at a high level. The outer of the double skin was refurbished. The inner had new glazing, more energy efficient. We then got 6 metre wide terraces about level 6, and then from then we have a new facade upwards. Again, all the kind of energy efficient coated glass, and also brise-soleil on different facade elements. And again, just another shot of the factory in Basildon where the facades were cleaned up and repaired when necessary.
It's worth saying, you know, this is just a shed they rented to do it. So all the stuff on the left has got nothing to do with the work on the facade, really. It's just very simple. They needed space. And the saving in transport on this by not taking this back to, this was originally manufactured by Schelderbau, not taking back to their factory on the continent was enormous when you just totted up what the carbon impact of simply not moving this amount of material around Europe.
So again, yeah, more kind of cleaning photos on site.
And Phil, I think the powder coating was all checked and tested. That was all durable. I mean, might have been beyond warranty, but
yeah, I mean, it was all in very good condition, to be fair. So we only needed to replace 1 or 2 glass panels. And again, we had kind of existing spares, so we were able to replace them like for like. Yeah, the samples that we had that we compared against the existing PPC again was pretty much kind of a perfect match. So there was very, very little fading on the existing. So kind of a testament to the kind of original quality of the building and the panels that were installed.
And the other key point of it was actually it had been assembled in a way you could take apart. So not only did we have the drawing, so we knew how it had been assembled and put together, it was all basically able to be dismantled. You know, the amount of silicon and adhesives in this was very low, really. So it's a simple mechanical process.
Yeah, just further shots of, so to the left is the image of the 3 metre by 3 metre glass panels that went onto the atrium roof, obviously to let all that light down into the centre of the building. And then to the right is kind of current status of the building from the plaza. So we've got the new entrance glazing in, GRC fins above that, and then new glazing above that one.
Yep. Okay, thanks, Phil. So as the project has gone on, we have probably about every 6 months refreshed our sort of calculations around where we are on the carbon content of the building, both in operational and embodied. Obviously, as a refurbishment of an existing building, there's an awful lot of that you gather simply from the existing structure, which is sort of, you know, 24% of this and then 20% of the substructure. But really everything else on that pie chart is the area we've been able to influence in the design thinking and the approach and the engineering and the work with British Land and with Lend-Lease to try and reduce, not just reduce the slices, but actually just make the whole pie smaller. So in a way, you could create the same diagram of this for a sort of new build, conventional sort of building that one might see elsewhere under construction. And not only would the pie be in a different shape, the pie itself would be much bigger, simply the carbon content and so on. So, and this is the work that our team within the sustainability team have been working on and developing tools within Arup as a whole, really, that now on all our projects we go through. So really, the last part of it is to say this is all about teamwork, really, has been the key enabling aspect of this in terms of actually the shared ambition. Thank you, Will. So back to you.
Thank you very much, and congratulations on the project. Really, really interesting, and not quite complete either. By the sounds of it, the fit out you were saying.
No, we were due to finish the shell and core at Christmas. Obviously, you know, the last 12 months have not been the easiest time to carry on constructing, but Lendlease have done a fantastic job at keeping the project going with all the support from their subcontractors. And we will complete the shell and core sort of in about the next 6 weeks or something. And then then the tenant team will come in and commence fit out, which I think is sort of the order of 12 months or something for them to fit out till it's fully occupied and alive.
Sure. And we've got a lot of questions coming in, which is great to see. So do add your questions to that list, but do please keep them short. The thing I wanted to start with, though, first was the point I think you made, Nick, a few times about the fact that you, as a company, had designed and engineered this building in the first place, and indeed for the same client. How, I mean, that was obviously crucial to the success of the project. So can you speculate what would have happened had it been a similar office building that you were dealing with, trying to do the same thing with, but had been done by somebody else?
I think there's two parts to that. One is, from a sort of technical design point of view, when you don't have all the information, many projects of this nature, people will spend an awful lot of time at the beginning, trying to recover records, trying to find records of piling, trying to find records of exactly what was built. Sometimes you find some of it, but not often do you find, and particularly, we keep very good records now when we finish a building, but probably back in the 90s and certainly the 80s, they were less comprehensive. If you don't have those records, you can't do the accurate re-engineering of the way you're using foundations or the way you're using structure and so on. And therefore, inevitably, there is a level of conservatism comes into the thinking about it. Yes, you can test things and so on, but there's an inevitability that you'll be more cautious and therefore you'll use more material in what you do thereafter. I think the other part of it is we were able to really interrogate the building and work out how simply we could unclip things and dismantle things. So the facade, the ability to take the facade off was entirely because we knew how it had been put together. And we were therefore able to make the case that commercially that was viable, that it wasn't something where somebody was going to price, risk. We all work on projects where you look at that figure that's called risk and scratch your head and work out, well, how do I change that? You've got to change an awful lot of other parts of the design of the building to reduce that number.
So the carbon savings would not have been as significant, and presumably the financial cost would have been higher.
Without those records, definitely there would have been an impact on that, yes.
And I guess that's why there's so much talk about material passports and the concept of the architect and the engineer acting as kind of building guardians, so they have a longer role and maybe get involved in further lives of that building. I mean, how obviously this is a special project and one that you're rightly proud of, but how unusual is it for Arup? Is this kind of the way you're going to be doing stuff? Obviously, you're not going to stop doing new builds, but
no. I mean, in a way, what we're trying to say is we don't think it should, in a way, be a special project. In 10 years' time, you'd like to look back and just see that actually, for most businesses, this is, the starting point when you look at a project like this. The principles of sort of circularity are entirely reliant on the quality of that information and data. you know, and the buildings we build now, if in 25 years' time we can keep doing what we've done on Triton, it's wholly reliant on whether, you know, the quality of the build in the first place was at the right level, and that the data is there that people can then repurpose and understand what they're doing. Otherwise, it will just be wasteful in material terms and so on.
But as you were saying, the cost is certainly on this one was marginal. You know, really not much more expensive than doing a comparable new build. So is that enough to convince clients in the, you know, in a kind of really important way, so that most clients go down this route?
Yeah, I mean, the cost premium was what we were trying to say, from going from excellent to outstanding was minimal, right, really, in the context of the sort of quality of building British Land would normally build, really. The increase there was minimal. Yeah, absolutely. You know, I would hope all clients, when they're sitting looking at an existing building, scratch their head really hard, understand what the embodied carbon in that building is before they start taking decisions to demolish. And really, I think that's beholden on all of us in current, you know, where we sit with the planet and climate change and so on. We have a moral obligation to be doing that with all our work.
But I've heard Rota DC in Belgium talk about the value of materials and building components, and they've been involved in, as you know, I'm sure, taking down, deconstructing buildings in places like Brussels, and finding that there is a market for those components. Is that something that you'd endorse here in the UK? Yeah,
absolutely. I guess there is just a question about, you know, one of the principles of circular economy is trying to keep materials at the highest value level that they sit at. That, you know, obviously you take materials off a high value building like this and move them down through the sort of the built environment. If you're then going to replace them with brand new prime materials, then you sort of got to question, you know, you've effectively, there's a gap there in that embodied value within the material. But absolutely, and I would hope that, you know, over the next decade we see that marketplace grow, so that actually when we're specifying things on the building, it's much easier for us to go out and look in that marketplace and go, right, well, we can buy there, and the supply chain believe they can get it easily, and therefore they won't put a premium on it. You know, which unfortunately recycled materials still carry that premium because people think they're hard to find or get, or be certain they'll meet spec, be warrantable. You know, we tie ourselves in knots with warranties.
Yeah. Okay, well, I'm going to turn to some questions from the audience now. First one from Duncan Walters, who asks, how specifically did the project compare against each 2030 LETI target, A1 to A5 and beyond?
Okay.
You may not know this.
I'm not sure whether Christina or Phil are close to that. No.
That's perhaps more one for the engineers.
Yeah, I'm not aware whether we've analysed it yet against the LETI targets or not. We've been doing quite a lot of work with LETI, so I suspect there is somebody I can go and find in Arup to answer that. I'm sorry.
That's okay. And Kirsten Kane asks, there was a saving of, was it 54% or 56% of embodied carbon? What was that compared with? Was it a typical London office building of the same kind of size?
The embodied carbon is compared with a new build office building to, I think it's the real estate benchmark standard. I mean, it's pretty close to a BCO type building. That's what that was compared with, taking similar spec.
Yeah.
Down to ground, including new foundations.
And a question from Paul Vick, who asks about what kind of cement replacement product you use, because I think you said that the new concrete you'd used was low carbon. Is that right?
Yeah, Christina, can you?
I'm not sure.
Okay, it was a GGBS.
Yeah, I think it was.
Mix, I think, wasn't it, Phil?
Yeah, 70% of the cement mix was the GGBS, and that was used for all the new structure. Apart from there were some walls down in the basement, which required a bit more kind of loading and required a bit more strength, so that wasn't used for that. But
so
yeah,
the piles, the 6 new columns we had to cast, and then all the floor slabs, I think, wasn't it?
Yeah, that's correct.
Yeah.
And Ben Hare asks, who says, thank you, great project and great talk. You mentioned that you managed to use 80% responsibly sourced materials. So what makes up the 20% that might be termed irresponsible?
Right.
These are tough questions.
Yeah, no, this is very, if Phil maybe or Christine, I'm not sure whether either of you close to the BREEAM assessment on that you might.
Well, I think it might be just down to kind of certification.
Right.
So in terms of the kind of the BS 6001, so it's quite difficult to get that certification for a lot of the materials. So we tried our best as much as possible to get a certification, but that is largely kind of think related to kind of UK products. So if we are looking at products that were from Europe, sometimes it was difficult to get those. So it's not necessarily that they weren't ethically sourced, but it's just it was difficult to get that, certification for them.
Sure. And a question about the materials. I guess this is looking beyond to perhaps this building having additional lives. Ralph Waterfield asks, how will Arup ensure documentation is available to whoever might want to do another refurb in 30 years' time?
Oh, well,
I guess
no,
this is about open sourcing, isn't it?
Well, it is. Yeah, there's two parts to that. I mean, we spend quite a lot of time digging out in our records. Arup, as an engineer, like a lot of the big established engineers in the UK, from time to time you get inquiries about previous buildings, and we keep our archive there, and we'll supply data on other buildings when asked. We're just in the middle of crawling through what the record drawings and documents look like for this building at the moment, which is pretty substantive. But those will be very key elements. So all the shop drawings, all the data from the construction side is preserved, and then on our own side, we're very sort of fastidious about how we archive our own design records and so on to make sure they are available.
I think just to add to that as well, all the new facade elements are tagged with little chips as well. So all that information is stored back with the facade subcontractor. So you can scan the panels and pick out the materials, right, elements that make up that panel, so on and so forth. So given that the subcontractor is happy to release the information later on, then that's all there stored.
Yeah, I suppose the other part of it is, I mean, we have this as a full Revit BIM project, and as it was designed as a multidisciplinary project. We've worked with our engineering colleagues and so on. So the architecture structural MEP model is a single model, and all of that is tagged and so on. And that's an important asset in its own right for future. And we're doing that with all our clients now in terms of going forward. So
yeah. And Wendy James asks if apologies if this was a point that you made, but was there any, could you give us any idea of the cost per square meter on this project?
I'm not sure I can declare that at this moment. We're closing out on completion, and the sort of final numbers on that.
So it's TBC.
Yeah, we'll be happy to disclose that when we're able to.
Sure. And how did you find, maybe this is a question you could all answer, how did you find working on this project as architects? Because, there is a sort of view, rightly or wrongly, that architects kind of prefer to work on new builds, having a blank slate, maybe there's a perception at least that there's going to be less creativity with something like this. How did you find it from start to finish?
I'll let Christina or Phil take that. Go on. Christina, you worked on it longest from the beginning.
Yeah, I guess I've worked quite a lot on the internal spaces. Yeah, I guess there is an element of it not being a new build and working within the constraints of an existing building, and there has been certain difficulties, particularly on site as we've gone forward, challenges that have arisen from that. But I guess seeing the bigger picture of what we've achieved now, we're coming to the end of the project. It's been super interesting and a lot of learning for me from joining this project as a part 2 through to this. It's been great.
And obviously you're tackling something very, very important. This is the kind of cutting edge, isn't it, of how we make the built environment sustainable. So that must be very satisfying.
Exactly.
I think in mature cities, this is, increasingly, I mean, Christina and Phil are a different part of their career than I am, but I think, this is going to make up an increasing part of what we do. We really have to look at an existing building, scratch our head. How can we make that work? And only if there's some real fundamental sort of misfit in terms of, what it can be used for in the wider sort of context of society are we going to be sitting there, taking things down. And I have a young son who's about to start architecture school, and I can see that his career is going to be a very different sort of profile of what my career has been like.
Yeah. Sorry, we've got so many questions. I'm just reading through them all. So Ali Ayad asks, what type of procurement strategy have you used on this?
Phil, do you want to?
So design and build
Uh-huh.
in this instance.
So we Lend-Lease were appointed at the end of RBA stage 3, which I think these days everyone would recognise now is a fairly well developed design. It's not like the old RBA stage D. It's well into old E. And Arup were novated across to Lend-Lease, and we worked with them through stage 4, all the packages, and then it was procured as a series of packages.
I think it's interesting because we did have kind of early engagement from the contractor as well and from the facade subcontractor, which is very, very useful. So we were able to kind of delve into the details of the facade and taking it off and put it back on at a very early stage, which was really beneficial for the project.
I guess the fact Permis Delisa, Gartner, Schelderbauer as a business is still there, which is not necessarily common among facade contractors sort of 25 years later, and that they were willing to engage and pick up what they'd done before was also a key part of the process.
Mm. And I think there was a slide that you used which perhaps was more about the rationale, the overall rationale for this kind of circular economy approach. And there was a bit of wording that said more carbon saved in design than will be produced in operation for 40 years. Is that, where's that come from? Is that a kind of generalization?
That's looking at the energy the building will use, and
right.
the carbon emission from that energy compared
the operational,
to it's the operational compared to the total carbon that the project has saved on the lease.
Yeah. And Stephen Howlin asks, did excluding the stairs from the thermal envelope save much in terms of carbon?
Well, it has in energy terms over 20 years. You're not heating those spaces. It saves some. And actually the point in a way is it's all the small bits do add up.
Yeah,
that was
this thing of marginal gains.
Yeah. So actually it's looking in every part of the building going, okay, step there, step there, step there. Don't just keep turning over the stones and seeing what you can do.
Was there anything, you mentioned that it was D&B, was there anything that precluded, with the sort of cost savings and the value engineering that came in? Is there stuff that you wanted to do that you couldn't because of that?
I don't think so. No, I think it was probably a smooth process. It was quite good.
It's a very open book, sort of collaborative D&B process. I mean, the D&B is as much to do with sort of giving the contractor the control and the ability to run the project the way they want. But it's a pretty open book process with the client in terms of cost. And equally, it's bought off a very developed stage 3 design rather than a sort of stage 2 sort of planning scheme where there's a huge amount of open interpretation.
And I'm sure it's very important that you had a client who wanted to achieve an exemplar here. That obviously you can make a lot of arguments to a client who might not be quite as on board about why it makes sense, but in this case it seems that British Land were really trying to push things as much as they could as well.
Yeah, well, I think you've seen from the conversations you've obviously had with them over the course of last year that the value they put on their impact on the environment at a corporate level and the strategies and policies they've put in place. If you go and talk to Juliette Morgan about the work she is doing within British Land, you know, it's really inspiring what they're trying to do and how they're trying to change their own mindset on all their projects, whether that's the work at Canada Water, the work they're doing in the city at Broadgate and so on. You know, those are all with similar agendas, different projects, different ways of playing it out, but the support they gave to the project, absolutely fundamental. If they hadn't been engaged with that conversation and really pushing it, then we wouldn't have been able to do what we've been able to bring to it.
Yeah. Now, a question about the steel. Robert Saculo asks if you could say a bit more about the reuse of steel. Did you have to melt it down and re-roll it, for example?
Well, no. It was all wrapped up in cement and concrete. I mean, it's just that's the it's a staggering figure when you look at the amount of reinforcement in an in situ concrete frame building like this. You know, designed in the early 90s with high loads. There is a lot of steel embedded in there. So I don't think, Phil, Christine, there's not an awful lot of exposed steel. There's some in the stairs, maybe, I guess, isn't
Yeah,
there?
it's mostly in the cores, and that was strengthened where it was needed to be.
Yeah. So no, Robert, I'm afraid we didn't take anything and melt it away. There was glass that was recycled. So there is some elements of glass that we weren't able to reuse. And so that was put back into the glass processing industry and was able to be put back in and melted. And
now a question about the fit out. Mathieu Dib asks, how involved will Arup be in the selection of material for the Tenant fit out to make sure the same goals are reached in terms of certification?
Yeah, well, the fit out's being designed by Shepherd Robson, but with their client Dentsu Aegis, they are aiming, I believe, at the same BREEAM outstanding. I think, isn't that right, Christina? Yeah. So they we're close in certain parts of the building, obviously in conversation, but we're not involved in that design work.
I think I know the answer to this, but Jonathan Jube asks, has the building been designed for future disassembly? I mean, I guess it hasn't because it was designed in the 90s and it's the same basic building.
It's the same basic building, but everything we've done is capable of being dismantled. So if we get further with some of the engineering thinking, there's an ambition to add more height to it at some point or change parts of it, then yeah, it's all essentially bolted together now.
Yes. And has COVID had any impact on the ventilation strategy? Because obviously there's a lot of talk about offices and the return to offices like this one. Is there anything that has to be adapted with that, or is the ventilation going to be appropriate?
Well, we had our air handling units on site and it plugged in by the time COVID came, so it's not going to have an impact on what we've designed. But the building is very good from that point of view. It's got 100% fresh air capability. It's a big displacement void system for ventilation, so it's already, in that sense, a very good system. But no, we're too far down the line, I'm afraid, to start making changes to things in light of COVID. And actually, I think we're all still working out what are the right responses to design changes to respond to COVID in that sense.
And what projects are on the horizon or the drawing board that are in some way similar to this for Arup?
Well, across the work we're doing in architecture, we have some very interesting work we're doing around retail buildings at the moment, starting to think what they might be repurposed into and how you might retain parts or all of those structures, but completely changing the use. The retail landscape's very, very different. You don't need shopping centres of the scale you've got. So we've got some very interesting work we're doing in that area. We've been doing some work with British Land on some very nearby buildings and looking at how those might be repurposed and enlarged, which is sort of, we'll see where that goes. And then our engineering teams are working both with us and with I'm sure a lot of the architects on this call across a whole number of projects with the same agenda, really. And there's some very good buildings up and down just the Euston Road where you see some of that work.
Yeah. Okay. Well, is there anything else? I've not really been able to ask all these questions because we've had so many. So apologies if you've asked a question and not had it answered. But is there anything, Christina, Philip, and Nick, that you want to add that perhaps we haven't touched on?
Phil, Christina, anything?
Not off the top of my head.
No.
Okay.
I would just sort of emphasize, I think, there's the questions you asked about how do you make this work for the next iteration is a really good point, that the quality of the information that we leave with the building is very valuable to the next generation. And so
you mentioned this thing of was it barcodes on
yeah, and little chips, yeah. ID tags.
Chips,
yeah.
Sorry, yeah.
And the other point really is just to re-emphasize, without the commitment of British Land and Lend-Lease to this, there is no way we would have been able to deliver what we're delivering. It's a holistic team effort, and as I'm sure all architects on the call know, if you're trying to push in a different direction from your client, it's really, really hard.
Yeah.
But it's really, really important we do this with all the projects we're looking at now. We think really hard about how we use material and what the carbon impact of it.
But by the sounds of it, it's not just, well, we know it's not just British Land that are interested in this sort of approach. How widespread is it now, among clients, would you say? I know that's difficult to quantify, but do you have clients knocking on your door saying, we want something like this, we've got an existing building?
We do. Yeah. No, it is widespread, but I think the stamina that's needed to go the extra mile to get that last 10-15% impact and so on isn't always there. And the commercial challenges are sometimes people, that word risk I mentioned, are often, all the way through projects sort of haunt some of the decision making around more challenging sort of innovations and so on. So it's there are lots of good clients are in that area and working hard at it. But I think it needs to be sort of, a universal acceptance. We must do this. Really.
Yeah, we need the government to start pushing
absolutely,
this in various ways, don't we?
I mean,
the levers of power.
Yeah, completely.
Yeah. Probably got time for one more question. And this probably kind of touches on your point, Nick, about the grid and how the grid's being cleaned up. Where Philip Banner asks, were you involved in the methods of heating and cooling? If so, what's being used here?
Well, yes, we were. We redesigned all the MEP systems. On this building, it does have gas-fired boilers. They're very efficient, and all the the MEP systems, whilst we replaced the plant and were constrained on area, the efficiency is radically different from what was there before. I think if we were designing this building now, grid permitting and infrastructure permitting, we'd be looking very hard at whether we were doing it all electric. And I mean, Arup, we're moving into building just developed next door to our offices on Fitzroy Street, which we've done the engineering on for Derwent. And that's an all electric building we're moving into. And on that building, we've gone right back to sourcing the electricity from a power provider who's using a regenerative system. So we've actually secured supply of that electricity from a known source that we know is green. And that I think is the future. Less gas is definitely where we're heading.
Yeah. Okay. Well, thank you so much, all three of you, for joining us this morning. It's been a really fascinating talk, and great to see so much engagement from our audience. So that concludes our AJ100 Club event for today. Thank you once again to our three guests from Arup Architecture, to our sponsors, and to everyone who's joined us. Apologies again for not being able to get to all of your questions. Our next AJ100 breakfast takes place in May, and my colleague James Maloney will be sending details out for that in due course. Thanks again, and goodbye.
Thank you, Will. That's great.
Thank you.